Okay, so people might be familiar with the things we were using, basically the tools. Like for example, we were using this collab to run and explore our data, to run the codes and all these. So today also the same thing will be starting with collab. So in the previous sessions we have seen how to explore data. So today we will see how to draw insights, how to draw different patterns in the data using different visualization libraries which are already available. The most popular visualization library which is available right now, it is using Python. This is Matplotlib. The visualization library is known as Matplotlib. So like why we use Matplotlib? Like Matplotlib is basically mostly runs hand in hand with Python, but there are different others also. Like for example, D3JS and HTML5 Canvas, which you can use in case of HTML and JS and all those. Like for example, ggplot and ggvis are there in the R language. So for Python, we'll mostly use Matplotlib. So starting with the Matplotlib, what are the things we basically need to know before starting this? Is that how to install Matplotlib, how to use it, and what are the different types? What are the different types of visualizations which we can see or which we can build using Matplotlib? So Matplotlib is basically a library. When you are using Colab, so let me share the screen. Okay. Yeah, is it visible?
Yes, it is visible.
Yeah. All right. So this is the Colab. So Google Colab. So first I'll connect to a backend runtime using this connect button. So while it allocates resources. So Matplotlib is such a library which we need to import it in our notebook or in our code before using it. So for importing Matplotlib is we'll write import Matplotlib as this is an alias name which is MPL, sorry, which are using. Then we'll be using import matplotlib dot pyplot. It's a sub package, you can say. We can, the most common alias name is PLT. So using this, matplotlib can be imported into our code. It runs successfully. So it has been included already in our code. Now in Matplotlib, once you've imported the Matplotlib library in your code, you can start using it. So Matplotlib basically works with some styles. So when you are starting using Matplotlib, you can say like plt.style.set .use classic. So this is the classic theme or the classic styling which we are predefining that Matplotlib will prefer. And then when you are displaying the different plots in the data, then you can use either this interactive window, which is this Jupyter notebook, or maybe you can use scripts like when you are writing a code and you are executing in the terminal, like Python space program name .py. So these are the ways in which you can use Matplotlib. So data visualization, starting with, is it is the graphic representation of data. It involves producing images that communicate relationships among the represented data to the viewers. So when you are doing machine learning, visualizing data is an essential part of data analysis. The popular library other than Matplotlib is Seaborn, which mostly people use to learn and apply some popular data visualization techniques. So here we'll mainly work with some charts or plots or maybe graphs. So you can treat all of them the same thing. And starting with, we have already imported this. Then we'll also import another library, which is for now, let's ignore this thing because the default style is already classic. So for other styles, you can already refer to their documentation and you can use other styling also. So we'll also import another library known as Seaborn. You'll see what we do with this next as SNS. So we have included this library. Now another thing, we'll write another extra line, which is this percentage matplotlib inline. So why do we write this? Does anybody know here why we write this line matplotlib inline? What is the purpose of this line? Anyone? Okay, so Matplotlib, there are two types. We can write Matplotlib inline or maybe Matplotlib notebook. So what Matplotlib inline does is it will lead to static images of the plot which is embedded in this notebook. And these will be static images. You cannot interact with them. So when you write inline, there will be static images will be rendered in this notebook and you can only see them. You cannot do any interactive operations using that. And when we write no Matplotlib notebook, then it is like an interactive plot which would be embedded within the notebook as you go and render them. So starting with to visualize something, we need some data. So let us define some data first before using that. So for example, first let me run this. Sorry. Oh, it is already done. So no need here. Okay, but for safe reasons, always include this. No issues. So first, let us define some data here. Let us say in the first session we were talking about some like arrays of like weather data, some fruits data, and all those things. So the similar thing. Let us say we are taking an array of, say for example, yield of. We are analyzing the yield of apples in a region. Say we are defining it as an array, say 0.568 comma 0.145 comma 0.823 comma 0.745 and all these. We are doing all 0 point because we want to do it between 0 and 1. So for making it easier, we are putting all values between 0 and 1, and another maybe say 0.901. Okay, so we have defined this array. This basically list or array yield of apples, and then now we want to view this, like for example when you are dealing with some data, you want to view this in a line plot. So when you are doing some line plot, say plt, which you have included as this alias matplotlib.pyplot, plt.plot, plot is the method through which line plots are generated, yield of apples. So we want to plot this as a line graph. See, this is the yield of apples. We have plotted it. These are the values. These are plotted, and this x-axis, these labels 0, 0.0, 0.5. These are randomly generated automatically. This is, and this vertical axis, the y values are those which we have provided here. Okay, so when we are providing only one argument, the x-axis labels, or basically these things, the x-axis labels or the horizontal values are decided automatically, but the vertical values are mapped with the thing which we are feeding it. And then, so a line plot is generated. Now, another thing we can do is like, now let us see how you can customize these. Say, for example, these are the yield of apples in, say, a number of years. Say, for example, in the first year, say it was 2001, 2, 3, 4, 5. There are 5 values. So let's say 2015, 2016, 2017, 18, and 19. So these are the 5 years. And then using this, we'll customize the x-axis values. So plt.plot, first argument will be the x-axis values, which are years list. Then there will be yield of apples. So let us see what kind of plot appears. See here, it is coming 2015, 2016. These are the values, and using this, and the y values are taking this yield of apples, and using this is plotted. This is a basically line graph which 2 values for each point, x and y. Now we can add some custom labels to this. Say plt.plot years yield apples. Then we'll add some label to the x-axis values. X label, say year, and y label yield of apples, say in kg, or maybe say, yeah, say kg. So after this, when we run, see, these are x-axis, we have provided a label which is year, and the y-axis we have also provided another label which is yield of apples in kg. So first we saw how to draw a line, then we saw how to customize the values on the axis, and then we saw how to customize the labels which are defining what values are there on the axis. Now this is a single line plotted in a graph, you can say, or this plot. So if we want to analyze multiple data, say for example, there are two cities, or maybe say in a city there are two different types of fruits, and you are trying to analyze the yield of the both the fruits versus year. So here, let's say the years array we are redefining, or let us say it is the same thing. Let us say oranges yield, and it is also another array. So 0.178, 0.265. Okay. This is another list of values. And now we want to plot both of this on a single plot. So let us see plt dot plot, and then we'll do serially. First we'll draw the first line. We'll draw one line at a time. First we'll draw the first line. So for that we need to feed the years list, and then the apples, sorry, yield of apples. Then we'll draw the next line, plt dot plot years, and say oranges yield. Okay. Now we'll define these labels. So we'll just copy here. Okay. So I'll just remove this yield. Okay. So let us see what appears. See, here the two lines are plotted basically. This orange one, it represents the oranges thing, and this blue line represents the yield of apples. So we are visualizing two types of data, the yield of two types of fruits versus year. So this way you can plot multiple lines in Matplotlib in a single plot or single graph. Now we have done these, we have customized the labels, we have customized the axis, we have already plotted the values. Now we want that, now in this graph, what we don't know that the person who is seeing this first, what he wants to know, what is this line, what is this second line. So he doesn't know which line represents what. For that we need to add a legend, which you used to do in map plotting or something. We used to add a legend, which line represents what thing. So let us also do that here, how to add some legends. So plt.plot, again years, yield of apples. Okay, then plt.plot years oranges yield. Then again these things, copy. So then we'll add a title to this graph. Okay, let us first also add a title, what this graph basically represents. So it is done using plt.title, and you can write the title here, say crop yields, or say yield of apples and oranges in, say, Kashmir. Okay, so this, the title is defined. Now let's add the legend, which line represents what. So plt.legend. Then we'll add a list of values again. The first one will be what? The thing which you have written at first. The first, all of this will be done serially. So this line will be drawn at first, the apples line, then the oranges line will be drawn after that. Then this X label, basically this value year will be written. Then this yield, this Y label will be written. After that, the title will be written. After that, the legend will be written. Also, this will follow the same sequence in which this is plotted. So the first value which will pass is the apples yield. The second value, say oranges yield. Let us see. See, okay. This writing may appear here. So to remove this, you can also put here a semicolon, so it will get removed. We are not doing it here since it doesn't matter here. Okay, so see, the title is written here in the first top of the graph, yield of apples and oranges in Kashmir. This is the legend. The blue line represents the apples yield, the orange line represents the oranges yield, and these are the X levels and the Y levels. Okay, so now we are seeing some continuous lines here. So let's say we want to know what are the points which have been plotted and the extrapolation has been done. So we want to add some markers, let's say. So for that, what we have to do, say plt dot plot again years yield of apples, and then plt dot plot years oranges yield. Okay, and in these two we'll add an extra argument which is marker, and we'll add equals to, say for example, one we want to write a circular marker, say O. For the next one we want to add marker equals to, say, X. Then again the same thing. I'll just copy from here, paste here. Let's see. See, the points have also been plotted here. This point was first plotted, then this, then this, then this. So the points which have been connected and extrapolated, so these have also been plotted in the graph. So these are the tools basically you may be needing the different in different ways, where you may be analyzing with different types of data, where you want to know which points have been plotted and all these. So these graphs, like we have customized, adding this labels, adding this legend, adding this title, and these markers. Also different other ways are there for customizing your plot. So you can use different lines and markers. You can also alter the color of the line. You can also alter the style of the line. Maybe it is this is a solid line here. You may be also wanting to do it with a dashed line. You may want to alter the line width, the marker size, the edge color of the marker, or maybe the edge width, and then the fill color of the markers. And the also an important field which you need to know is how to control the opacity. Opacity means that the transparency basically of each individual plot. It will not be so required here, but as we move to other types of plots, it becomes very important, this alpha thing. So like we added this marker argument here, we'll also add an alpha argument, which is any value between 0 and 1. So now let us see an advanced plot using different customizations which I said. Say plt dot plot, first is the years, then is the yield of apples. Then let's say we had already added the marker equals to, say, O, and let's say the color we are specifying it blue using B. Now say the line style. So these are the different stylings which you can use. So you may choose here as it is a solid line or maybe a dashed line. So you can do that using this single hyphen. So it is a dashed line basically, or maybe solid line you can also prefer. Then we'll use the LW for the line width. Let's say we're taking it 2 here. Then say we are adding marker size. So the marker size we can customize using like anything greater than 0. For example, we can add like 8 or maybe 10 or anything. So marker size we've already defined here. Another is like markers edge width. So markers edge width is another number basically. So we are using, for example, 2. Also for this, say, another thing which I said is the edge color for the marker. Say for example, we are using MEC and let's say navy. These things. So we'll do it with a single plot only. For the other thing also we can do. So we'll again define this plt.x label and the y label, and we'll add a single legend. So we don't need a legend here since it's a single plot only. Now let's see one plotting what happens. So we have customized this marker, this the color, the line style, or the line. This is the solid line. We can also use a dashed line, line width, and all these customizations. So other types of customizations are also there, which are available in the Matplotlib, which is user documentation. You can refer to that. Other than this, proceeding with this, we can also using all these customizations may be a bit hectic, so we can punch, or maybe we can merge all of this or 2-3 of this into a single thing. We usually call it as an FMT parameter. FMT basically is the first argument is the marker, and the second argument is basically the line and the color. Using all these, so we can this is a single argument which we can also use here to shorten this whole thing. Okay, so all of this is given in the document basically. No need to go into all those things, since when we need it, we'll already go and see into that. Okay, so we can also, this we are working with the fixed size figure, so we can also proceed with the figure, different size of figures. Say for example, you want to customize this whole figure and you want to resize it. Say for basic plt dot figure, and this fixed size argument, which you can give like anything, say 18 and 8. So this basically customizes this whole graph which is given here. And after that, when we plot and use that thing using, say, this too, so the whole thing, the size of the plot basically changes. See, this comes a bigger graph in comparison to the previous thing. You can use it using this fixed size argument. After that, when we are using these things, so once Matplotlib was developed, then a few days later, it was seen that Matplotlib had some limitations and issues due to which it could not be continued. Already, it is a strong library till today, but another library which was built on top of Matplotlib library came into existence, which was known as Seaborn. So Seaborn, why was Seaborn basically built? So Seaborn usually helps us in plotting some data frames. So when we saw about the pandas data frames, there were some series and some data frames. While we are plotting using Matplotlib, we need to plot each series one by one. Whereas in Seaborn, we can already do that. We can feed a single data frame to that, and it already splits it into series or whatever it does in the backend. But we don't need to individually do that ourselves. It already handles that itself. So say for example, using Seaborn, which already imported at the top here, import Seaborn as SNS. So we'll be using this here. Let us see. So Seaborn is nothing but a library which is built on top of Matplotlib. So SNS, then dot, we can set style, or we may proceed with the default style which is already there. So the set style, we can say like it's a white grid. So white grid will be rendered here, and based on that, we can do different plotting and visualizations. So after that, we can also plot whatever we had already done earlier. Say years, this thing. And then the FMT parameter which I said, like we can give here what the different types of customizations are there. 3 at the same time we can give. Say for example, we are giving here S and a hyphen, then B. This is a specific customization. And say for the second thing also, we are giving plt dot plot, say years, oranges, yield. And also here we are giving a different kind of customization, say dashed line and red, and this is the plot style. So first thing is the line style or the marker style, then is the line, what type of line will be drawn, a dashed or a solid line, and then is the color. Okay, so these things we can combine into one argument. After that, we can plot it just as we did here. This thing, this thing. So X label, Y label, title and legend has been done. Okay. So see, this was the previous thing which we had already done using Matplotlib. It was these things, this thing basically. So when we are using Seaborn, a different kind of some extra graph and some advanced visualization. See the library, the rendering of the whole graph basically improved in comparison to what we were using in Matplotlib. Also, another type of styling is there, which you can set here. So this is white grid. You can also use as dark grid. Then when we render, see the graph turned dark. So these things can be done, and based on this, different customization since Seaborn is also there. So moving on to this, Seaborn also has a lot other advantages also. The Seaborn library also has a few data sets included in which we can already pull into our code by writing a single line. So we'll see that. So until now, we had already seen the line plots and the visualizations and the plotting of the line plots. So another type of plot is there, which is basically known as the scatter plots. So we'll see when scatter plots actually came into existence and why we use scatter plots. So when we were using line plots, it was a single data. I mean a single point, say a single value. Now when we are dealing with 2 points for each data point, say for example an x and y coordinate of each point. So in those cases, we will be basically using scatter plots. So instead, let's first import a data set basically. So there is another data set known as the iris data set, which usually contains the sample measurements of the sepals and the petals for 3 species of flowers. The one was Sentosa, one was Virginica, and another was a different thing. So let's first include that data set, flowers data frame, say sns dot load data set, then it's iris data set we are including. Okay, and let's run this. Okay, so plus underscore tf, let's print it. What data frame we can. So this is the data frame which consists of 150 rows and 5 columns. Each consists of the sepal length. These are basically flower characteristics of the flowers: sepal length, sepal width, petal width, and the species of the flower. So there are 3 types of species. One is Setosa, Virginica, another is there. So now we want to plot each of these. Now let's see the limitation of line plots here. Say for example, flowers underscore df dot. First, let us see how many types of species are there. Dot species dot unique. Let's see how many unique values are there in this species. Saying 3. Let's verify. Yeah. So one is Setosa, one is versicolor, and another is Virginica. Now let us try plotting this whole thing using a line plot. Let's see what happens. Plt.plot. First argument is the data frame object, which we have already created. And using this, the first characteristic which we want to plot is say anything, say sepal length or sepal width, anything. So we'll be plotting the sepal length versus sepal width for each flower in the database. Sepal length and flowers dot sepal width. Let's see what happens. See, this is what happens when we are drawing this using a line plot. Some kind of this scribbling happens, and from this we are not able to draw any insights or any inference from this whole data frame. So this is where scatter plots come in. So scatter plots basically help us to visualize data which has 2 values or the x and y, say 2-dimensional values for each data point. So now let us try plotting this using a scatter plot. So sns.scatter plot. Now we'll be feeding this. The x values will be fed with the sepal length of the flowers dot sepal length, and the y values will be fed with the sepal width. Let us see. So this is what happens. So now each individual sepal length versus sepal width. Now each is a data point here. Each blue dot here represents a data point. So this is what happens in scatter plots. Now say the data points are already plotted, but we aren't able to draw any visualization. So we can only see how the whole data is distributed, the values, the sepal length versus sepal width, the values we can draw insights from this. Now we want to customize this. We want to add different colors to the different species of the flowers as we are plotting their sepal characteristics. So now we'll add a different argument here, a separate argument, which is the hue. So this we'll in copying here and we'll paste here with the hue which is equals to, and then we'll pass the parameter which is basically representing this. Say for example the different types of species. So for a single type of species, a single color will be preferred. So flowers df dot species, sorry, species, yeah. And also another argument will be giving here for making these dots a bit larger, the size argument, say 100. So run this. See, now different types of species are plotted using this scatter plot using different colors. Each species represents a different color. The blue ones represent the setosa species, the orange color represents the versicolor, these species, and the green ones represent virginicus. So now a better inference can be drawn from this. We can draw some inference, say what kind of species have their sepal characteristics at what places, like which values they basically oscillate between. So now, just as we saw in Matplotlib, we can also customize the figures which we are drawing in Seaborn. Okay, so like this. Now, since the Seaborn is built on top of Matplotlib, many things go hand in hand. Like we can also use the plot thing, plt dot. The customizations can be done using this plt dot figure, the fig size which we saw there, using which we can make the whole figure larger or maybe smaller, whatever you wish. So we use 18,8 there, whatever else. Now we are setting a title to the whole plot, which is say sepal dimensions of flowers. Now we are drawing this using, now the customizations has been done. Now we are drawing this using SNS scatter plot. X equals to flowers data frame dot sepal length. Y argument is basically flowers data frame dot sepal width, and then the color for the hue thing we can do flowers data frame dot species, and again the sizing which is 100. Now let's see what kind of customizations have been done. See, the first of all, the customizations which we did here was to increase the size of the figure, was to add a title which is the sepal dimensions of the flowers, and then we also did these things, the plotting the points, differentiating them using colors, and then increasing the sizes of each plot or each data point. So this has been done. Now we can now the thing which I said earlier is was what was the benefit of using Seaborn and this Matplotlib. When we are feeding these things separately, then what is the benefit of using this Seaborn? It was also been done in Matplotlib. We are feeding different series individually. We are doing this part ourselves, but I said that it can also be done. We can feed a whole data frame to this, and it can already separate the various series and it can plot itself. So how can it be done? What is the benefit of scatterplot now comes into existence? Say we are using plt.title. First we are setting the title, which was let's copy from here. We are setting the title of the plot. Then we are plotting directly sns.scatter plot. First I'll give what is the x label. So we'll first feed the x label. So we'll say sepal length. Say sepal length. This is the not the x level, sorry, this is the values which will be taken in this x axis. So the x axis, the sepal length column will be taken. For the y axis, the values in the sepal width will be taken, and the rest things remain same. The hue will be taken as the species column, and the s remains 100. Now we are feeding another argument here, which is this D means the data frame which we are feeding, or means the data. This, sorry, data. This we are feeding the data frame which is flowers underscore data frame. So these are the arguments for the X. This will be taking the X values. The Y will be taking the Y values. That is the sepal width. This species column will be attached with the hue, and the size will be 100. And from the data frame, which is flowers underscore df. So here we were doing it like flowers underscore df dot sepal length. We were explicitly specifying which values to take. But here we are only mentioning the columns. It will already extract and it will feed. Let us see. See. So this has been done. Now, if at any point we want to say like change this, say for example petal, we want to go with petal length and petal width. We'll just put here petal length and petal width. Now let's see. See, now this is a different plot which is using the petals. So this is this easy. Just put in what values you want to take from the data frame, then feed which based on which the color should be determined based on which column, and then the size if you want, or else this is optional thing, the sizing thing. Else the default size will be taken, and the last, which is another compulsory argument, is the this data frame thing. You have to feed that. So in this way it is done. So we have seen the line plots, we have seen the scatter plots, which were mainly used to plot two-dimensional values, say which were having an x and a y value for each data point. Now we'll see another type of plot, which is histogram, which you may be familiar with. Most of you must be familiar with histograms. In the earlier classes it had been done. A histogram basically represents the distribution of a variable by creating intervals along the range of values and showing vertical bars to indicate the number of observations in each interval. Okay, so we'll see how it is done. Now, say for example, we want to visualize the distribution of values of sepal width in the this data set. So another function is there, say hist function, hist. So first let us initiate this flowers. Oh, it is already done, no issues. So let us see flowers df dot say sepal width. Let's see what values are there. These are there. 3.5, 3.0, 3.2, these things. 150 values are there. First, we have to divide it into some specific intervals, and it will be plotted using some vertical bars. So if we don't provide any specific interval length ourselves, then the default interval lengths will be taken. So first, let us see how to plot this using histogram. Say we are providing a title of the plot first. So distribution. So it is basically why are histograms done. Histograms are done to visualize the distribution of any values, or a set of distribution of a set of values across specific intervals. So here we are analyzing the distribution of the sepal width across different intervals. Say for example, between 2 and 3, how many values are there? Like how many flowers are having sepal width between 3 and 5. So these things we can do. Distribution, say for example, the title distribution of sepal width. Now we are plotting this histogram using, sorry, hist flowers underscore df dot sepal width. See, so these many values are there, like between different intervals. So here it is taking 0.5 as the default interval. So 2, 2.5, 3, 3.5, 4, and 4.5. Between, so like between 2 and 4.5, all the sepal weights are there. Who is having the mic unmuted? Please mute. Now we can also, like I said, like you can also control the interval length. Say like you don't want to take it in like 0.5 intervals. You want to say customize it, and you want to take it between say 3 intervals, say 2, 2.3, then 2.6, and all like this. So you can also customize that, or you may be also be able to customize the number of categories which you are dividing, which is using the bins argument. Let us say plt.hist flowers data frame dot sepal width, and this bins means the number of intervals. So this is controlling the number of bars which will be there. Say, uh, say you want 6 bars. Now let us see. See 1, 2, 3, 4, 5, and 6. In 6 parts, all of this is done. So you can control this, the number of bars using this. Accordingly, the data will be distributed automatically. So this is one way of like by which you are controlling the number of categories. Now we will be doing the range of each category. So we can do it like we'll be using this numpy. So let us import this here. Import numpy as np. Then like plt dot hist flash data frame dot sepal width. Then the again this bins equals to np dot arrange from 2 to 5 using interval of 0. Say 3 or say 0.25, anything, whatever you want. So between 2 to 5 this whole data will be distributed, and each interval length will be of 0.25. Let's see what happens. Oh, sorry, a range. To say range. Yeah. So 2 to 5, see each interval is of 0.25. Say first interval is this, then this, then this. So between each pair of values 2 and 2.5 are 2 bars. So accordingly, the whole data is being distributed. Now you may also want to like customize this using different bars of unequal sizes. You can also do that. So you can just have to do here, like in the bins thing, you have to write like this: bins equals to the, say you have to provide the set of values, like say 1, say the next will be of 3, then 4, then 4.5, and all this. Just put this here and it will be done. Let's see. Okay, sorry. So the unequal types of intervals which you want to prefer, maybe. So this is done, like histogram is done. So using histogram, we usually visualize the distribution of a set of values across specific intervals. Now we'll be moving on to another type of plots, which are known as the bar charts, which you may be familiar with. Bar charts, it was in PowerPoint and many things they were being done, and different data analysis tools also use these. So these are like the different separate histograms. So say for example, for this Setosa, so this was a species, Setosa data frame. So we are taking this equals to flowers data frame and flowers dot species, where flower species are only Setosa. So we are taking out the Setosa species into this data frame. Similarly, we'll be taking out the others also. So another was there. What was the versicolor? So another thing, which was I think Virginica. So these are the different types of species we have taken out into individual separate data frames. Now we want to plot these using individual, say, colors. For example, say now we want to plot any two of them using histograms. plt.hist setosa data frame, and we'll be plotting it sepal width. Now here comes the alpha parameter, which I said like will be important when you are drawing multiple graphs which may be coinciding. So you want to bring out the separation between them by controlling its transparency, which is done using this alpha argument. So alpha, let's say we are giving as 0.4, then bins equals to again np dot arrange 2 5, say 0.25. Okay, now the same thing we'll do for this thing. I'll just copy. this thing also, say versicolor. Okay, so this alpha also 0.4, so the transparency will be 0.4 for both. Okay, uh, okay, it is done. Now let us see what happens. See, the two bar charts have been drawn. I mean, not bar chart exactly, you can say the histogram of two different uh, data frames, or two different series of values have been drawn here. Now another thing we can do here, say, now see, there are two types of patches here. See this blue patch over this orange one, these are the colliding ones, which we have taken in that alpha argument. Now another thing which we may need are like when we want to stack multiple histograms on each other. So we'll just pass another thing like stacked equals to true, another argument we may pass here. So it will stack one on top of another. Okay, so let's see how it can be done. So another, we are setting the title distribution of sepal width. Now we'll be saying plt.hist setosa data frame, and we'll be taking in the width, then the versicolor, the second data frame will be feeding again sepal width, and then virginica also will be taking sepal width, then bins and p.arrange 2,5, of each interval 0.25, and we'll pass another argument which is stacked equals to true. Okay, okay, we'll give the semicolon also to remove this extra line which comes in at the top of the graph. Then we'll be drawing the legend. First is the setosa, and the second is the versicolor, and the third is the virginica. So now let us see what happens. We are basically drawing the whole thing in a single histogram, not different things. First we saw how to draw a single series of values on a single histogram. Then we saw how to draw two values on a single, I mean two distribution on a single histogram. Now we are seeing how to draw three things on a single histogram. Now here these overlappings we'll be removing. We'll be using this stacked true. So one will be stacked on top of another. Let's see what happens. See, so here no overlapping is there. So basically this green one, see the bigger, the highest bar, the green one has been extended to the topmost point. So basically this green one is also beneath the whole thing. So it is not like it is only covering from this around 30 to around 50. It has been covering from 0 to 50. Then the orange thing which is protruding from the top of the blue thing. So orange thing basically starts from 0 and continues till around 30. So this thing. So this is the way you interpret a stacked graph, or the stacked plot you can say, or stacked histogram. Now say another type of plotting is there which is known as bar charts. So we'll be taking a simple set of values, say years we are already defined. So years are there, apples were already there, oranges. Okay, so let us plot that. PL, we'll be using those values, plt.bar. So first is the years, and then the oranges yield. Let us see. So this is a bar graph. Okay, so also it can be done like, again stacking can be done here. Say plt.bar years oranges yield, then plt.bar years yield of apples, then we can also specify another additional parameter or argument, which is this bottom. So which one will be at the bottom? Say for example, we take this orange yield at the bottom. Now let us plot. See, it has been done. So this is the stacked bar plots. So this can also be done. Now also different other kinds of things are there. Say with mm, we can work with some averages using some bar plots in Seaborn. Now another data set is there, which is the tips data set. This data set contains the information about the gender, the time of the day, the total bill, and the tip amount for customers visiting a restaurant over a week. So let us take into account that data set once. Excuse me. Yeah. So tips, let us take it into a data frame. Tips data frame, which is equals to sns.load dataset, and here we'll be adding this tips. Also, let us see what comes here. Reprinting. Okay, so this is the total bill of the customer. This is the tip amount which he gave. This is the gender or sex. This is the is the person, was the person a smoker or not? What the day and the time, the lunch or dinner or breakfast, anything, and this is the size. So different parameters are there, and now let us see what we can do using this. Now we want to draw a bar chart. Let's say we want to draw a bar chart to visualize how the average bill amount varies across different days of the week. I mean, this is the whole list of data, like say 244 rows, say 244 occurrences are there. 244 different bills are there. We want to see on which day the bill was highest and on which day less customers came into the restaurant. So these things. So we'll be using bar plot to analyze that. So let us see how bar plot comes into play here. SNS dot, we'll use the bar plot of the Seaborn here. SNS dot bar plot. The X value will be basically containing the day. The Y value will be containing the total bill amount, and the data of the data frame will be this tips data frame. Let's see what is this bar plot. So the Seaborn has this advantage. When we were drawing bar plots using Matplotlib, so it was only giving the data which we were wanting it to give. And when we are using Seaborn's bar plot, it is also giving us, it will also give us some extra information. It will also compute the averages which we are wanting to see, let's say. But we are not telling it that calculate the averages. It will calculate it automatically. See, it is quite the same thing which was here, the on top of it, the matplotlib thing, but here some extra lines are there on top of each bar. So what do these represent? So basically these things, these bars represent the values which were the total bill amounts of each day, and this is the average thing. The lines cutting each bar represent the amount of variation in the values. For instance, it seems like the total bill is relatively high, or maybe the total bill is relatively high on these Fridays and it is relatively low on Saturdays. Okay, so this is the inference which we can draw from here. So we can also specify a hue argument, so to differentiate between like different things, or maybe we also want to analyze based on some other parameters. Let's see. So that hue argument is also available here. Bar plot x equals to the day, and the y argument basically takes in the total bill amount, and the hue is the gender of the person, and the data is basically the data frame, tips data frame. Let's see what happens. See here, on the basis of gender also we can see like how many male customers came, how many female customers came. So using this we can compute different requirements, like different kinds of data analysis which we may be requiring to analyze the sales of a specific restaurant and all these. So this varies on different use cases. So using this we can also plot different distributions of data. Okay. So also here the same, the black lines on top of each bar, this also represents the variance in the values, or the how the values are vary. I mean, they can uh, you can say they can change between these values. The max one will be having the top of this bar, this line, and it can vary between this bottom point of the line. So these things you can already analyze using this. Another thing which is important here is basically another type of chart. So we saw line chart, we saw scatter plots, we saw histograms, we saw bar charts, and another, yeah, this SNS bar charts also, which also gives us the computed averages. We also saw this. Another important one is there, which is one of the heat maps in Seaborn. So which is also used to visualize some two-dimensional data like a matrix or a table using colors. So let's take it as an example and see. So another dataset is there in Seaborn, which is the flights dataset, which visualizes the monthly passenger footfall at an airport over a number of years. Let's say we'll see the heat map. This is also an important visualization. SNS.load dataset, the flights dataset, and the, let's set the pivot. We want the month, we want the year, also we want the number of passengers. Now let's print this. Okay. So this is the data set which usually this represents the footfall in a specific airport for the last uh, 12 years it is given. So for the 12 years data it is providing. So what is this? What is this flights data frame? It is basically a matrix with one row for each month and one column for each year. This 1949 for each month, these were the footfalls. For 1958, these were the footfalls. Like for example, in the January months varying over the years, these were the footfalls. So this is basically a matrix. So how can we evaluate this whole thing using a single plot? So here is where heat maps come into play. So let us see how we can visualize this thing using a heat map. We'll be first setting the number of setting the title of this, say the uh, passenger footfall at, let's say, Kolkata airport, say in thousands. And then we'll draw the footfall, the heat map. Okay, it just needs a single parameter, this whole matrix or the data frame. See, this is the heat map. So how to analyze this heat map? This is a gradient of colors are present here. What do each of these represent? So see the way here are some dark colors as well as some bright colors, and it varies over the different years and the different months. So the brighter colors here usually indicate a higher footfall, as you can see in this legend, which is given in this right. That is starting from 200 at the bottom and going up till 600, around 600 values. So as the value goes high, the color becomes lighter, which represents that the brighter colors indicate a higher footfall at the airport. So using this, what inference can we draw from here? We can say that the footfall in the airport at any given year tends to be high around when? Say this is varying across the months. So the brightest portion is between this June, July, August, this thing. So around this July and August, the highest footfall is there in any year. So another thing which we can draw from this is that the footfall at the airport in any given month, which it is tending to grow year by year. Say for example in 1949, see the whole column across all months, the whole column was dark. Then it became, as we moved on to 1950, 51, 52, 53, the colors became lighter. And as we are moving on to 1960, see the colors become the lightest. So which represents that the color is moving from a dark thing to a bright thing, which means that the footfall is increasing year on year. Also, we can actually represent the actual values which are there in each box by specifying another argument, which is known as the annotation. Let's see, again we'll be copying this. Also here we will be giving some extra parameters, fmt, which I already said. This is a customization, nothing else. And annote this, or annotation will be feeding this true value to this, and there is a color map argument which will be given true. Will be sorry, not true, blues. So color map is nothing but this thing, the right, the whatever thing is present in the right, this blues. So all blues will be there. So the color palette will be basically set using this. Now let's plot this. See, in each box the actual values are being represented. You can also see the values are growing year on year, 112, 115. See the first row, it is growing till, see, 417. Again, for each year it is growing. 1949 it is 118 in December, and in 1960 December it became 44432. So to re-verify or to cross verify, you can use this. You can also plot the values on each box. Now Matplotlib has another important property, which, like, you can also use it to display some images, but that is an optional thing. You can learn it on yourself only. It is not such a great thing. So there is another library which is PIL, Python imaging library. Using this you can also plot some images you can show. Okay, so should I show that, or I mean, it is a very simple thing, like it won't be needed much at all when you are analyzing things. The charts are the things only which would be required in different data analysis and visualizations. All right, another thing is there, you can use some pair plots. Say for example, in a specific graph you want to see some subplots all at the same time. Say for example, you have drawn all of these graphs, now you want to see all of them at the in a same single graph. How do you see that? So you will do that basically using this. So just focus on this becomes important. So figure and axis equals to pl, we will be using the subplots feature to do this. Plt dot subplot, this 2 by 3, and each figure size, say 16 by 8 or maybe 18 by 8 or anything. So these things are there, and for each subplot we'll be referring, so it will be returning a set of figure and axis which will be having its own index values. For example, say for example the axis 0 comma 0 dot plot. Axis 0 comma 0 means it is referring to the first subplot. Basically this is returning some specific spaces. It is allotting some specific spaces to draw plots in. So for the first space we will be drawing this plot, years and yield of apples, and this another fmt, that thing. Then for example, say let it remain. Say for example the next thing we want to say 0 comma 1. So this is basically the array or list indexing which you had already done. The same thing works here. Set title sepal length versus sepal width, and SNS scatter plot. We'll be drawing this x equals to flowers data frame dot sepal length, and okay, so we'll just copy this. What is this? Yeah, this. Not this. Let's take this. Yeah. Okay. Let's delete this. Another argument which would be needed here is the ax, which represents on which axis this will be done. axis 0 comma 1. So using this multiple things you can plot. So this the first thing, it is the subplot 1, you may say subplot 1, and for the second thing which is coming here, it can be said as the subplot 2, and like different subplots are there. So here basically 2 into 3, so 6 can be drawn here. I'll be showing only 2 here. And after doing all these things, we can say like another padding we can give, say plt dot type layout pad equals to 2. I'm showing using only 2. See, the rest are empty plots. So using this, different things can also be done. Say for example, I want to copy this, and I'll be just setting this is the subplot 3. So this will be 0 1. Say this is 1 0. Say 1 1. Say 1 0, and say 0 2. Let us see. So yeah, I've just repeated here. So different subplots can be drawn like this. In a single plot, when you want to see different visualizations at the same time, so you can use this subplots feature, and you can draw, you can refer to different points. In this graph, you can refer using 0 0. This graph using 0 1 0 2, then 1 0 1 1, then 1 2, and all these things you can do. So I think this is it. Another thing is there. Say for example, when you are, say you are analyzing a data frame and you want to see all kinds of combinations of whatever kind of plots are able to be drawn using different columns which should be drawn. So there is another thing which Seaborn has. It is known as pair plot. So let us see how it is done. SNS, it is a very short thing. Say SNS pair plot. First argument is the data frame, and the second argument is say the hue, which is the species. Let us see all kinds of combinations which are there, it will be drawn. See, so these species are only taken to refer to the different types of colors, but all pairs of values are here. The all pairs of values and their plots are basically given here. So using this pair plot thing, it can be easy to do. Similar thing we can also do using this tips thing, sns.pair plot, and the first argument is basically the tips data frame, and the second hue equals to say the gender. Can also be done. Yeah, so these are the different things. The blue one represents the males and the male customers which were present during that week, or maybe that particular day of the week. Uh, and the orange ones were representing the female customers in that restaurant. So this is the size versus total bill, this graph. This tip versus tip is this. So this tip versus total bill, tip versus size is this. So these different kinds of plot are there. So this was it. Another set of advanced visualizations are there, but we'll be learning them as we'll be needing them. This is it. For the basics of the plotting, I think these things will be enough for us be good to go. So another short session will be needed. We'll be doing it after a few more sessions on, but immediately we'll be moving on to exploring some more data analysis, and we'll be building our first model after learning some algorithms. And for this, what you have to do is like just go through these things. We'll be giving you the links where the different documentations of these is there. Yeah, another thing I want to mention is like when you are working with some short data sets, or short, maybe you say short data frames, So these NumPy, this Matplotlib, all this is good. But when you are, I am talking this in terms of data manipulation part. When we are using NumPy, pandas basically. So pandas is usually good when we are working with some short data frames. But when we are actually moving to big data, so in the recent times, big data is currently into existence. So there are different other things also. Say for example, one is Dask and another is Vax. So these things we'll be discussing in a short session in the next whenever we'll be meeting. So just if you want, just go through that, and we'll be also exploring with some more advanced visualizations how to build dashboards and all these things. Okay, so yeah, Swadesh, you want to introduce the quiz right now? I'll just stop sharing.
Yes. First, I
Yeah, anybody's
should
having any
stop the
doubts?
recording. Let me just pause the recording first.